Welcome back. In part 1, we covered closure and commutative. Now let's explore the associative property. If you have 3 or more rational numbers and you change how they are grouped using brackets without changing their order, does the final answer stay the same? Let's check this with an example. First, group the numbers like this: 1/2 plus 1/4, then add 1/3. 1/2 plus 1/4 gives us 2/4 plus 1/4, which equals 3/4. Now we add 3/4 and 1/3. To do that, we take the LCM of 4 and 3, which is 12. So we write 9 plus 4 over 12, and that gives us 13/12. Now let us look at group 2. This time we group the numbers like this: 1/2 plus 1/4 plus 1/3. Start with the bracket 1/4 plus 1/3. To add this, we take the LCM of 4 and 3, which is 12. So we write 3 plus 4 over 12, which gives us 7/12. Add 1/2 and 7/12. LCM is 12, so we write 6 plus 7 over 12, which gives 13/12. Same result again. Let's make it simple with marbles. You are collecting marbles from 3 friends, Amit, Bimal and Chetan. First you take marbles from Amit and Bimal, then from Chetan. Now flip it. Take from Amit, then from Bimal and Chetan together. Will you get the same number of marbles? Yes, because it doesn't matter how you group them. The total stays the same. That's the associative property. We saw that addition is associative, but what about subtraction? Let's explore that. We start with 5/4 minus 1/2 minus 1/4. Let's first solve 5/4 minus 1/2. LCM of 4 and 2, that's 4. Now adjust the numerators. 5 minus 2 over 4, that gives us 3/4. Now subtract 1/4. 3 minus 1 over 4 equals 2/4, which simplifies to 1/2. Now group it differently. 5/4 minus 1/2 minus 1/4. Start inside the brackets. 1/2 minus 1/4. LCM is 4 again. So 2 minus 1 over 4 equals 1/4. Now subtract. 5 minus 1 over 4 equals 4/4. That is equals to 1. 1/2 and 1. That's a different result. So subtraction is not associative. Remember our 3 friends Amit, Bimal and Chetan? Earlier they were adding marbles. Now they are giving them away. Amit has 10 marbles. He gives 5 to Bimal. Then Bimal gives 2 to Chetan. So 3 marbles are left. In the second way, Bimal first gives 2 to Chetan, and then out of 10, the remaining 3 is subtracted, which gives us 7. Wait a minute, same numbers but different answers. That means subtraction is not associative. Multiplication time. Say we have got these 3 fractions: 1/2, 2/3 and 3/4. Let's group the first 2. 1/2 times 2/3 first. That's 2/6, which is the same as 1/3. Now multiply that by 3/4. 1/3 times 3/4 is 3/12, which is 1/4. Cool, right? Now let's mix up the grouping. We will do 2/3 times 3/4 first this time. That gives us 6/12 or 1/2. Now 1/2 times 1/2 is equals to 1/4 again. Boom, same answer. So that means multiplication is associative. You can group them however you like and the result won't change. But now let's try division. Let's start with some friendly whole numbers 16, 4 and 2. First we group like this 16 divided by 4, then divided by 2. 16 divided by 4 is 4, then 4 divided by 2 is 2. Alright, now we switch it up. Let's divide 4 by 2 first, that's 2. Now do 16 divided by 2 and we get 8. Wait, what? Same numbers but totally different results. Yup, that means division is not associative. So with division, grouping matters a lot. Now let's talk about the distributive property. The math rule that's all about sharing smartly. Here's the idea. When you multiply something outside brackets, you can pass it along to everything inside. Let's say you are at a party and you grab 2 snack boxes. Each box has 3 biscuit packs and 4 chocolate bars. Now the big question is, how many total snacks do you have? Let's solve it in 2 ways. The first method says, add first, then multiply. Each box has 3 plus 4 equals to 7 snacks. So 2 boxes gives you 2 multiplied by 7 equals 14 snacks total. Nice and simple, right? In the second method, we distribute like a pro. Let's count biscuits and chocolates separately. 2 into 3 equals 6 biscuits and 2 into 4 equals 8 chocolates. So 6 plus 8 equals 14 total snacks. Same result. That's the distributive property in action. Now let's try it with fractions and subtractions. What's 1/2 times 2/3 minus 1/3? In the first method, we subtract first. 2/3 minus 1/3 equals 1/3. Then 1/2 times 1/3 equals 1/6. Now distribute. 1/2 times 2/3 is equals 1/3. 1/2 times 1/3 equals 1/6. Now subtract. 1/3 minus 1/6 is equals to 1/6. Again, same result. So next time you see brackets, just remember, share the multiplication and simplify the problem. Alright, let's meet 2 superheroes of the number world, 0 and 1. First, let's see the power of 0, also called the additive identity. Let's try something. What's 3 over 5 plus 0? Yep, still 3 over 5. And what is minus 2 plus 0? Still minus 2. Adding 0 doesn't change anything. It's like giving someone nothing. They stay exactly the same. Now time for the magic of 1, our multiplicative identity. Try this. 7 over 8 times 1. Still 7 over 8. Minus 4 times 1. Still minus 4. Multiplying by 1 leaves the number unchanged. After identities, we have inverses. They are all about undoing things. Imagine this. You earn rupees 50. Then you spend rupees 50. Oops. Now you are back at rupees 0. Earning and spending, they cancel each other out. That's exactly what the additive inverse does. Take 2 over 7. What's its opposite? Negative 2 over 7. Together they balance each other out. So for any number a, the additive inverse is minus a because a plus minus a is equals to 0. Now meet the next inverse, the multiplicative inverse, or as we like to call it, the reciprocal. Take 3 over 4. Its reciprocal is 4 over 3. Multiply them and you get 1. Just like that, boom, we are back to our identity 1. So for any non-zero number a, the multiplicative inverse is 1 by a because multiplying both of them gives us 1. But wait, what about 0? Can we multiply anything with 0 and get 1? No. 0 into anything is equals to 0, not 1. So 0's the rebel here. It has no reciprocal. It's game show time. I'll ask and you answer. Let's go. Can I regroup numbers and still get the same result? Yes, if it's adding or multiplying. Can I spread multiplication over addition or subtraction? You bet, that's the distributive property. What happens when I add 0? Nothing. That's the additive identity. What about multiplying by 1? Still the same. That's the multiplicative identity. How do I cancel a number in addition? Simple. Add its opposite.